All right. Exactly. All right. So when it says lnx, has anyone heard of ln before? You bring up a good point, sir. One of my friends lives in Arizona, and I was helping. He's an engineer. Well, he was going to be an engineer, and he worked in construction. Anyway, he was going to take an engineering exam, and he called this lawn X, and I was like, I laughed in his face, and then I felt bad because you shouldn't laugh at people when you tutor them. That's rude. And he was like, "Why are you laughing?" Because they really call this lawn X, and I was like, "That's very strange of you. Why do you call it that? Are you weird or?" There's just something short-circuited in your brain, but apparently there are places where they call this lawn X. I've never heard that before, but I just wanted to say it to you in case you go to a school where they do that. LNX is what I've always heard, but apparently there are places out there like Arizona where they call this lawn X. And he kept calling it that the whole time I was tutoring him, and I wanted to smack him every time, but it was over Zoom because he was in Arizona and I couldn't do it. But I do want you guys to know that if I had tutored him in person, I would have punched him in the face for the lawn X because it bothered me that much. So how would you like us to say it? LNX. Can I say no. No. No, this is not a computer operating system. So, but thank you for that reference. All right, my dad would be so proud that I caught it. All right, so lnx is actually the same as y equals log base e of x. Same thing. But nobody writes log base e of x. Nope, they write lnx. So whenever you see lnx, you're going to go, oh, okay, that's a log with a base of e. Yes. Yep. 2.718. So let's go ahead and write that. 2.718. Is that right? Now I'm second guessing myself. Hold on. Handy dandy calculator. Yeah. I still got it. All right, so let's write that important information off to the side here. So we got the vertical asymptote, x equals 0. We got the point 1, 0. And the point base 1, so in this case it's E1. So x equals 0 for our vertical asymptote. 1, 0. And then 2.7181. It's about there-ish. Now, when you get into upper levels of math, they like hardly ever use log graphs. They only use ln. So by the time, if you are on the advanced math track, you choose to come to calculus, we completely ditch all of the log stuff. We only use lnx. That's it. That's the only one we use. And we refer to this all the time. All the time. Students will be like, Miss Rice, can you ln 0? And I say, no, that's a vertical asymptote. Okay, that's right. Miss Rice, can you ln a negative number? And I say, no, remember the vertical asymptote's there, so there's nothing for the ln of negative numbers. Oh, that's right. Miss Rice, what's the ln of 1? Oh, it's 0. They ask me these questions all the time. So this is a very common graph in calculus, like super, super common. Oh, I forgot to make the foop sound. Foop. Okay. It cannot. The God's already spoken. It's me. No. Because I said. Yes. Because even though it looks like ln, it's still log base e. So it's still a log graph, so it's still slow moving. Increases, but increases very slowly. All right. Just like we did yesterday, I'm going to say these transformations over here, ditto. All right. Now at the bottom, actually, I'm going to write this right up here. This is the natural log. Okay, natural log. lnx is the natural log. Why isn't it NL? Why is it LN? I don't know. It's log natural. It's probably Latin. That's why it's backwards. Log natural. I don't know. Okay. At the bottom of the page, don't turn the page yet. Have you guys, well, actually, look at your calculator. So you have an LN button. That is the LN that we just talked about. Now you have a log button. This is not log base 2. This is not log base 3. This log button down here, we're going to write it at the bottom of our page. Y equals just log x, like this, is actually, and this is the log button that you have at the bottom of your calculator. This is actually y equals log base 10. And this is called the common logarithm. Okay? Sorry, I will zoom in when we get to specific examples. This is the common logarithm. Log base 10 is the common logarithm, okay? So sometimes people write it with a base of 10, but a lot of times people don't. So if you ever see the word log and it doesn't have a base, the base is 10. That's the common logarithm. So we have ln, that has a base of e. We have the common logarithm, that has a base of 10. Those are the only two logs you will ever see where the base is not clearly written. The rest of the time, the base will be clearly written for you. Okay? Does that make sense? Okay. All right. Let's go ahead and turn the page. All right. So this one, let's go ahead and type this one in our calculator. We did everything else. We just hadn't found the x-intercept and y-intercept. So we're going to hit the y equals button. We've got 2 ln x plus 5 minus 6. So we're going to use the ln button. So we're going to type 2. Hit the ln button, ln. There we go. It's underneath the log button. It's above the stow button. ln, right here. X plus 5 minus 6. There we go. Just by looking at the equation, can you guys tell what the vertical asymptote is? -5. So vertical asymptote is the opposite of the inside. Vertical asymptote is -5. Okay. So make sure my window is normal, should be okay. Go ahead and graph that. There is my log graph. Now, the thing that is kind of annoying about these, and I made sure to give us an example like this one on purpose. Remember how I said these are slow growing? They go up very slowly. Just because it doesn't cross the x-axis on the screen does not mean it never crosses the x-axis. It just means it didn't do it on the screen, okay? So with this one, I can see it's approaching the x-axis, but it hasn't crossed it yet. That doesn't mean there's no x-intercept. That means I haven't found it yet. So we need to hit the window button. We need more positive x values. So if you hit the window button, which number here do you have to change? X max, what do you guys think we should change it to? 15. Okay, we change it to 15. We are maybe not quite there yet. What should we change it to? 20? 25? To 25. There's no harm in going too big. Okay, so 25 was definitely enough. Okay, so now I'm going to hit what? Second trace, option number 2. And I am just going to tell my calculator, hey calculator, look somewhere between 0 and 25, because it's there. There we go. Yeah. So when we hit 15, we were almost there, but not quite. All right, how do we find the y-intercept? Second trace, number 1, plug in 0, unless you are James, you are smarter than the rest of us, and then you hit trace and plug in 0. All right, so we got 0. Keld, why are you throwing tennis balls at us? Y coordinate is negative 2.781. Okay, are we comfortable with that? Okay, I'm going to show you guys another way to plug this in your calculator. Okay, leave this on the screen. I'm going to show you another way. So hit the y equals button. Go down to y2. I'm going to show you that these are the same. Okay? So this way, we're going to type in log base e x plus 5 minus 6. Okay? So here is, I'm going to write another form, and I'm going to write this on our notes because it's important to know the different ways you can type this. So here's another way. Is y equals 2 log base e of x plus 5 minus 6. Okay, now this log base e, this e does not have an exponent. It just says log base e, and then that e is of x plus 5. So since I have log base e and the e does not have an exponent, I'm going to use the e that is above my division symbol. That's just a plain e. That e is not automatically asking for an exponent, okay? So here's what I'm going to do. I'm going to hit the math button. And when you hit the math button, there's a list of different things here. You can scroll down the list, but it's easiest to get to this if you go up, up. You can scroll down to get there, but it's easiest to remember to just go up, up, okay? Does everyone see that your option here is log base? Okay, go back though, we have to put the 2 in first. So put the 2 in. That was my bad, I should have made us do that. Okay, now once we have the 2 in, hit the math button, go up, up. Okay, now we're going to have log base, and we're going to put that e in there. So you're going to hit second division symbol, log base e. Everyone got that? Log base e, x plus 5 minus 6. Everyone have that typed? Okay, hit the graph button. Now, nothing new is going to be graphed. Those of you with a color calculator are probably going to see that color, that new color, replace the old color, because what just happened is that new graph replaced the old graph. Those are the same equation. They're exactly the same. That's why we're not seeing a new curve. Does that make sense? Okay, I'm going to show you another way to graph this. This is called change of base. This is how people with old calculators used to do it, because on the older calculator, we used to not be able to type in a new base. We used to only be able to use the ln button and the log button. So we couldn't type in, oh, a base of 2, oh, a base of 3. We couldn't do that, okay? So if we wanted to do a base e, there was no way. So here's how we used to do it in the older calculators. We type 2, and then we would type log of x plus 5 divided by log of e minus 6. This is called the change of base formula. This, for Math 3, is a little bit outdated. In Math 3, nobody uses this anymore because the TI calculators are smart enough and updated enough that we don't need this. This change of base formula is still used in calculus, which means you're not going to see it this year, nobody cares, but my calculus students still see this sometimes. So it's beneficial to see it. So do you guys see how they came up with this? So what they did, see how this is how I remember the change of base formula. See how the x plus 5 is a little bit higher and the e is a little bit lower? They took the higher, they put it on top. They took the lower, they put it on bottom. Does that make sense? Higher goes on top, lower goes on bottom, and then they make it a division problem. Okay, so we're going to type this in. You're going to see how it works. So a person with an older calculator, they would not have had the opportunity to use that fraction button. So a person with an older calculator would have said 2, and they would have used the log button. So the log button is above the ln. They would have said log, the log button, x plus 5, divided by log button, and then the e, and then minus 6. That's what somebody with an old calculator would have done. So Annika, before I updated your calculator yesterday, this is how you would have had to type all these problems. Okay? So this is how it would have been typed. Okay? Everyone see that? So the reason I'm showing this to you is because I know some of you guys are on that calculus track. You're interested in going into calculus. So 2 log of x plus 5 log of e. Now, since this doesn't have a base, what is technically the base of this log that I just put in there? It's base 10, okay? Let's go ahead and hit the graph button and see what happens. It looks exactly the same. That means all 3 of those are all 3 different equations that actually graph the exact same curve. And if we hit second graph, we can see all 3 of these are y1, y2, and y3 have all the same points. You guys see that? Okay. So I just wanted you guys to notice that those were all the same. I'll probably a few more times show you guys how to do that just so that we can reiterate that those are actually different ways of plugging in the same thing. How are your brains feeling about that right now? Does that make sense? Kind of okay? Now, do you have to do that every time? No, you can just plug in the original. Okay? Your calculators, I think in this class we have all the updated calculators. We can all just plug in the original graph. The original was just using the ln button, plugging it in like this. Yep. Okay. Last page. We're going to go ahead and graph these by hand. So, how do we start? Vertical asymptote, and what is it for example 5? -1. Okay. So an exponential graph had the point 1, 0, so we're using the point 0, 1. The exponential graph had the point 1 base, so we're using the point base 1. I think these are backwards. 1, 0. 1, 0. There we go. Okay. The way that I remember these, this is your exponential graph, right? I can always remember the points from the exponential graph because they make sense to me with the exponential graph. If you put 0 in for x, what's anything to the 0 power? 2 to the 0, 3 to the 0, 4 to the 0. What's anything to the 0 power? You plug it in your calculator to check. Not 0, it's 1. Anything to the 0 power is 1. And then if you plug in 1, what's 2 to the 1, or what's 3 to the 1, or what's 4 to the 1, or what's 5 to the 1? It's just the number itself. So I always remember the 2 points based off the exponential graph because to me the 2 points are really easy to find from the exponential graph. So I always remember the 2 points from this, and then to get them for the log graph, I just flip them. That's how I remember these points, because otherwise I would not be able to remember them. So in my head, I always go through this, plug in 0, get 1, plug in 1, get b, and then I go flip. That's how you'll teach it. Okay, so what are the transformations for this equation? What do we have? Reflect over x, which is going to impact the y coordinate. What else? Left 1 and up 5, and then what's the base? Okay, so I'm going to go in here, I'm going to change my base to 2. All right. So if I reflect over x, what do my points become? Don't you dare kick that tennis ball all the way down the hall. Keld. I feel like his dad. All right. So how do I reflect over x? Change the y to negatives. Okay, so we got 1, 0, and 2, -1. And then so far that vertical asymptote, I know it's going to end up at 1, but I don't know, it's compulsive. I still have to do it. All right, so we did the first transformation. Now I've got left 1 and up 5. So what is the left 1 going to impact? The x value. So it's going to impact the vertical asymptote. That's where we got the vertical asymptote of -1. And then we're going to go left 1, left 1. Okay? And then for all the points, we have to go up 5. So we're going to take the y coordinate and we're going to add 5, and we're going to add 5. Okay. So I drew my vertical asymptote at -1. Now I've got the point 0, 5. And then I also have the point 1, 4. I always start with the point that's furthest away. And then I go towards the asymptote. I follow it towards and follow the asymptote. And then on the other side, I go whoop. That didn't whoop very well. Ta-da! Whoop. You tried it and you liked it because it's a nice sound. Whoop. Whoop. Ka-chow doesn't fit, and then I ka-chow, and then it's too much. It's too much.
I think ka-chow is better. Ka-chow is better. I think when you have those two, all in favor of ka-chow instead of ka-chow. We're allowed to use ka-chow.
You can use ka-chow. You're just wrong, but that's fine. All right, next one. So we got the vertical asymptote is going to be where? +3. Okay, so let's go ahead and draw it. Okay. And then what are the transformations? Right 3, up 4, and then what else? I can see one more. A vertical stretch of 2. You saved that giraffe's life very quickly. Vertical stretch of 2. And then what's the base? Base is 4. Okay, so for base, we're going to have 4, 1. Okay. So vertical stretch of 2, what does that do to the points? Double. Takes the y and doubles it. So 0 double is still 0. And then 1 double becomes 2. 1 times 2 is 2. Vertical asymptote is not impacted yet because it's an x value. Okay. And then we have to go right 3 and up 4. So what should I do for the right 3? Add 3 to the x, so x equals 3 to our vertical asymptote, and then 4, and then 7. Okay? And then up 4, up 4, up 4. So we've got the point 4, 4, and 7, 6. Okay? So we're going to start with the point furthest away, draw towards the point, and draw towards the asymptote. Follow along the asymptote there. And then we're going to, whoop! Not, what is it, ka-chow? Ka-chow! I don't even know what part to emphasize there. Ka-chow! 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 Ka-chow. No, whoop! It's a nice little, it's a whoop! It's a little whoop! That's too jump, like, it's too, no. I reject that. All right, and so we have an assignment like yesterday. I know you're shocked. When you guys come back.